This experiment with a candle, a jar and some water is simple, but quite marvelous. The candle is lit, covered by the jar, and then something amazing happens. Water is sucked into the jar as the candle is going out. Although a possible explanation might seem straightforward, this experiment is often explained incorrectly. So let's take a look at the correct explanation. To understand what is going on during the experiment, it is necessary to look at what happens on the molecular level when a candle is burning. To do this, I'll have to make some assumptions. Firstly, I assume that the chemical structure of candle wax is a long chain of carbon atoms, with 2 hydrogen atoms attached to every carbon atom. Secondly, I assume complete combustion of the candle wax. These two assumptions made the reaction equation for burning candle wax very simple. The reaction equation actually shows something quite strange. By assuming ideal gases, it says that the volume of gas on the left side of the equation is smaller than the volume of gas on the right side of the equation. For this experiment, this would mean that you would not expect the water to be sucked into the jar, but rather the opposite. However, it all changes when the candle has spent all the available oxygen in the jar and goes out. This will cause the gas in the jar to cool down, which has two effects. Firstly, the cooling gas will decrease in volume, sucking water into the jar, but more importantly, the water vapor formed by the burning of the candle will condense due to the cooling of the gas. Because water vapor takes up much more volume than liquid water, this causes the volume of the gas in the jar to decrease even more, sucking in more water. The interesting thing is that with the reaction formula, it's possible to make a prediction for the volume of water that will be sucked into the jar due to the condensation of the water vapor. It will be exactly 2/3 of the volume of oxygen in the jar, which is known at the beginning of the experiment. This makes it possible to make a prediction for the water level at the end of the experiment, which will confirm or deny this hypothesis. So let's have a look. In this video, the top line on the jar represents the volume of oxygen at the beginning of the experiment. The bottom line represents the volume of water vapor that will be formed by the burning of the candle. This water vapor will condense and, according to our hypothesis, will be equal to the volume of water that will be sucked into the jar. Thus, the water level should stop rising exactly at this line. And as you can see, this is exactly what happens, which is a strong indication that the condensation of water vapor is indeed the correct explanation for this experiment. This condensation is even visible through the glass of the jar. Okay, thanks for watching and see you next time.